Hi everyone, welcome to our lesson 3.1. We're looking today at the sine law, and we're looking at the sine law as it applies to acute triangles. Let's go ahead and get started in our 3.1 notes. So acute triangles and the sine law, before we go ahead and look at what the sine law is and how it relates to a triangle, we need to first just clarify a few different terms. And the first one is an acute triangle. An acute triangle is made up of three angles that are all less than 90 degrees. So if you're looking at a triangle, and I can see here that 55 degrees, 80 degrees, and 45 degrees are all less than 90 degrees, this is an acute triangle. We're also going to be looking at ratios in this lesson. So let's talk about a bit about what a ratio is. A ratio is just any two things that are written one over top of the other. So numbers, for example, 2 over 4, a fraction is a ratio. And an equivalent ratio is another ratio that is equal to that ratio, such as 1 over 2. 1 over 2 is equivalent to 2 over 4. They are the same amount. If I divided this one by 2 and this one by 2, I'd get an equivalent ratio. Okay. Another equivalent ratio, I could have a larger ratio such as 10 over 20 or 20 over 40. And all those three ratios are all equal in value, so they are called equivalent ratios. The last thing that we need to look at before we go ahead and talk about sine law is the primary trig ratio, the sine ratio of an angle in a right triangle. So in your notes here we have recall the primary trig ratios. Hopefully you've seen these before. If not, that's okay. You are given these ratios in Math 11. But when we have a right triangle, there are three primary trigonometric ratios that we can use for that right triangle. The sine of an angle is equal to the ratio of the opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent side over the hypotenuse. And the tangent of an angle is equal to the opposite side over the adjacent side. That's a ratio. So each of these are ratios. The ratios of side lengths, and they're equal to the sine, cos, or tangent of that angle. You might have come across this phrase SOHCAHTOA before, and SOHCAHTOA is just a great way to remember the three trigonometric ratios for a right triangle, where the S stands for sine, the C stands for cosine, and the T stands for tangent. And the other two letters in each ratio tell you which sides to put in the ratio. So here, if we look at it tells me that the sine of an angle is equal to the opposite, the O, over the hypotenuse. Okay, so that's just a really quick way to remember it. We're going to be looking at this ratio here, the sine ratio for a right triangle, because it's what allows us to prove the sine law. Let's think of a right triangle for a minute. How about the triangle ABC, like so, where C is our right angle? I could label this right triangle. I could label all the side lengths. And the first thing I can always label is the side that's right across from my right angle. So in every right triangle, the hypotenuse is always the side that's across from your right angle. There's your hypotenuse right there. The other two sides of this triangle will depend on which angle I'm looking at. So I'm going to go ahead and choose angle A here as my angle of interest. We always have to pick an angle of interest when we're using a trig ratio. The side that's directly across from my angle of interest, in other words, the opposite side from my angle, is called my opposite side. There's the opposite side from C to B. And the leftover side, the one you haven't labeled yet, is your adjacent side. Okay, it makes the other arm of the 90-degree angle. Okay, that's not the opposite here. So this is called the adjacent side over here. A to C would be adjacent. When we use the sine the sine of an angle is equal to the opposite side over the hypotenuse side. In this case, if A is our angle that we're interested in, the sine of A would be equal to my opposite side. So if I knew the length of that, I could substitute that into my ratio over my hypotenuse. So opposite over hypotenuse. Okay. We're going to be using this trig ratio to prove sine law for an acute triangle, which is not a right triangle. But this is important to us. So let's go ahead and look at what is sine law. So sine law is a law that allows us to find missing angles and sides in an acute triangle, as well as in other triangles also. But an acute triangle, I notice, is not a right triangle. Okay, so I know that all three angles are less than 90 degrees, and it's definitely not a right triangle because one of the angles is not equal to 90 degrees. But I could take an acute triangle and I could divide it right in half and make it into two right triangles. And we're going to prove sine law by looking at this acute triangle, and we're going to divide it right down the middle. So let's go ahead and make this the triangle ABC. So let's call this the triangle ABC, where I label each of my vertices ABC. And I'm going to divide this triangle right down the middle. So I'm going to start at the top point of my triangle, my vertex B, and I'm going to come down and just draw a straight line, oops, straight as I can, right down the middle of this triangle so that it intersects the line AC at a perpendicular. It's a perpendicular relationship that's a 90-degree angle there on both sides. So what I've done is I've just divided my triangle in half. I now have two right triangles. And let's call this the height of the triangle ABC. So we'll call it H. It represents the height of that triangle. All right, so now that I've divided this acute triangle into two, I see that I have two triangles. So I have, first of all, I have a triangle on the left and a triangle on the right. So in the triangle on the right, okay, if I go ahead and label that triangle on the right, I could label the side lengths here. So I would have let's call this length right here from A to B. Let's call that little c. So it's right across from angle C. Okay, we're going to call that C, right across from angle C. And we're going to go ahead and call this side length B to A, little a, lowercase a, because it's right across from angle A, okay, which is a different angle. So right across from angle A. We could use the trig ratio for sine to label our triangle. So if I were to look at the sine of A, okay, in my right triangle on the left, the sine of A would be equal to the opposite over the hypotenuse. This is always true. So let's go ahead and look at that for a minute. So I'm talking about angle A right here. Okay, so let's label this little right triangle that we have on the left. So right across from angle A, okay, would be H. So H would be my opposite side. It's opposite from my angle. And across from the right angle, opposite the right angle, is my hypotenuse. So C is my hypotenuse. Okay, which means that the sine of A is equal to the opposite, which is H, over the hypotenuse, which is C. Okay, the hypotenuse, which is C. So I have the following. Sine of A is equal to H over C. In my second triangle, so in the triangle on the right, I have a right angled triangle on the right. Sorry, folks, made a little bit of a mistake here. I apologize. The first triangle we were looking at was the triangle on the left. So sorry, just make that change in your notes. So for the first one that we did here, that was the triangle on the left. Sorry about that. Apologize. So we were looking first at angle A, which was the triangle on the left. Now if we look at the triangle on the right, so if we look at angle C here as our angle of interest, and if we label this little right angle triangle relative to angle C, then H, the height of the triangle, again is going to be the opposite side because it's right opposite from my angle C. And the hypotenuse of this right angled triangle is going to be right here, A, little a, okay, or the length B to C, because it's right across from my right angle. So if I were to take the sine of angle C, I get, again, sine of any angle is equal to the opposite over the hypotenuse. And so for this other right triangle, the opposite is, again, H. And this time it's over A. Okay, because the hypotenuse here is the side length A. So I get these two trig ratios for my two right triangles. And what I know is true for both the triangles is that they have the same height. So the opposite side, H is equal to H. The opposite sides have the same length in both of my triangles. So this is true. H is equal to H, which allows me to go ahead and rearrange my two equations and set H equal to H. So let's go ahead and do that. So if we rearrange 1 and 2 to solve for H, okay, if I go ahead and look at, for example, for the first one. So for 1, we said that the sine of angle A is equal to H over C. And so if I just rearrange that, if I cross multiply sine of A by C, I get H all by itself. So the sine of A times C is equal to H. And number 2, I have the sine of C, of big angle C, is equal to H over A, and I can rearrange that in the exact same way. If I want to isolate H here, I'm just going to cross multiply what's on the bottom so that I get the sine of C times A is equal to H. And I'll go ahead and put my A in there. So, and if I set H equal to H, that means that the sine of A times C is equal to the sine of C times A. So if H is equal to H, then this is true. Okay. What I have here is, this is the basis of sine law. I could also write this statement, this equal statement that I have here, as a ratio. So as a ratio, and I'm not going to ask you to prove sine law, I just want you to see where it comes from. So if I were to divide both sides by the sine of A, and also divide both sides by the sine of C, I would get the following. Okay, here's my ratio. C over the sine of C is equal to A over the sine of A. So I've just gone ahead and divided. I want to get my C's on one side, my A's on one side. So I divided the left side by the sine of A, and I did the same thing on the other side, which brought the sine of A over to the right on the bottom. And then I again divided both sides by the sine of C to remove it on the right-hand side, which brought it down to the left-hand side. So I get this ratio right here, that side length C over the sine of angle C is equal to side length A over the sine of A. And this is sine law. So this is the proof of sine law. Let's go ahead and then look at how sine law applies now to an acute triangle. So you don't have to prove this every time. This is simply to show you where it comes from. And you're given sine law in your in your data booklet. Oops, sorry, folks. Let me just, I've lost my, sorry, folks. There it is. Okay. So we can use sine law for any acute triangle, and it's called a side angle relationship. So a side angle relationship is called sine law for an acute triangle, and it's given to you in your data booklet, and we're going to write it down here for ourselves in our notes, and it looks like this. Okay, if we have an acute triangle and we are to label it, so the angle A is across from side length small a. So in our acute triangle, the side length that is opposite from an angle, we will label that with the same letter but in a lower case. Okay, so we'll use a capital letter for angles and a small letter to represent our side length. Okay, across from angle B will be side length B, and across from angle capital C will be a little c. So this is a big C here, and a little c is the side length directly across from it. And sine law looks like this. It says that A, side length A, over the sine of A, the sine of angle A, is equal to both the other ratios in this triangle. So the side relationship with its angle, the ratio of those are equal for all three of these angles in this triangle. So side length B over the sine of B is equal to A over the sine of A, and the side length C over the sine of big angle C are equal to those other two ratios. So those are true. We could also write this by flipping these or taking the inverse of all these ratios. So the inverse ratios are true as well. So I could flip all of these so that I have the angles on the top such that sine of A over side length A is equal to the sine of B over side length B. So I'm just taking the denominators and taking the inverse, and I'm putting the numerators on the bottom and denominators on the top. And the sine of C is equal over side length C is equal to the other two ratios. So these are really, really useful for us. Sine law is given to you in your data booklet, so you don't have to memorize this. But let's go ahead and use it then. How can we use it? Well, if we're going to be looking at a triangle, we need to know at least 3 out of 4 pieces of information. So for example, if we were looking for this side length B in this triangle, I need to know at least another side length. Okay, I need to know the angle B, and I need to know another angle A if I know side length A. Okay, or it's also true if I knew C and the sine of C, I could also set those two ratios equal and solve for B. So I need to know 2 out of 3 pieces of information in order to use sine law. Let's go ahead and try this with an actual question. So we've got a triangle here. It's an acute triangle. Let's label this triangle A, B, C. And we're going to be given, let's say we're given a couple of angles here, 30 degrees for angle A, and we're given 70 degrees for angle B. And let's say that we are given the side length A to C, and it's 13 centimeters. Okay, and that's all we're given. And we're asked to find the remaining missing sides using the side angle relation. Okay, and we can also figure out the angle C quite quickly as well. The first thing that I'm going to do is go ahead and label my triangle. So angle A is right here, and this side across from it then is going to be called side length A. Angle B, 70 degrees. Across from angle B will be side length B, and I know that measurement is equal to 13 centimeters. And finally, my last angle here, angle C, if I needed to use it, okay, I don't have it, but I could figure it out just by taking 180 degrees and subtracting the other two. And the side across from it is going to be side length C. So we go ahead and label our triangle in this way so that we can use sine law. And now let's go ahead and look and say to ourselves, well, what could I figure out here? If I look at A, side length A, I see that I have the angle directly across from it. Okay. I also have angle B and I have side length B. So I have a complete ratio for the sine of B over B. That's true. Okay. And I have the angle A, so I could figure out what is the side length A. So we're going to go ahead and start there. Let's find the side little a. Okay. Well, A over the sine of A, which I know the sine of A, is equal to, it's true that it's going to be equal to B over the sine of B. It's also equal to C over the sine of C. But notice that we don't have any information yet for angle C or the side length C. So I'm going to use the ratio for B over the sine of B, because I have side length B and I have the angle B, so I could figure out what is the sine of 70 degrees. So the only thing that I'm missing here is angle A. So I'm going to use the ratio, a complete ratio that I have, as well as the angle A, so that I can solve for my side length A. So we're going to go ahead, let's substitute in all the information that we know here. So I don't know side length A, so I'll leave it like this. But I know that angle A is equal to 30 degrees. And that's equal to my ratio for B, my sine ratio for B. And B is equal to 13 centimeters. And angle B is equal to 70 degrees. So on the bottom, I have the sine of 70 degrees. At this point, it's really important that your calculator is in degree mode, or you will not get the correct answers here. So your calculator must be in DEG degree mode. If you're looking at your calculator, when you're doing some questions, you'll see it may say grad, radians, or degree, and you want to make sure that it's in degree mode. Okay, if you're trying one of the questions from our notes, you should be getting the same answer as me, and that tells you you're in the correct mode. Okay, so let's go ahead and solve for this. The only thing I want to do here is isolate A, so I need to just get rid of the sine of 30 on the bottom. So I'm going to just cross multiply, okay, the bottom by the top of my other ratio, or in other words, I'm going to times both sides by the sine of 30 to get rid of the sine of 30 on the bottom. So I get A is equal to, on the other side here, I'm going to have 13 centimeters multiplied by the sine of 30 degrees, okay, divided by the sine of 70 degrees on the bottom. So we go ahead and do that in our calculators. 13 times sine of 30 equals divided by sine of 70, and I get for this is equal to, let me go ahead and put in the values just in case you're checking your work right now. Okay, so what we'll get here is 13 times the sine of 30 is equal to 0.5 divided by the sine of 70, which is equal to 0.93969 if I leave a few decimal places there. Okay, and so we get a value of 6.91716. And I was looking for A, which is a side length, so that's going to be in centimeters. And there is my value for the side A. So I could go ahead and round that. Let's have a look at the other values that I have. I think it would be, I don't want to round it right to 7 here. Let's leave one decimal place. So let's round that to 6.9 centimeters, just to be a little bit more accurate here. Okay, so 6.9 centimeters. So I can come up here and say A is equal to 6.9 centimeters. So we just used sine law to solve for A. I could also now solve for C using sine law, but in order to solve for C, I do need to figure out what is angle C. So we could do that. Let's find angle C. Angle C is just going to be equal to 180 degrees, subtract the other two angles that we have. So subtract 30, subtract 70. 70 and 30 is 100, so angle C is equal to 80 degrees. So we can go ahead and fill that in right here, 80 degrees for angle C. Now that I have that information, I can find side length C. And I have two choices here for side length C. C over the sine of C, okay, is equal to A over the sine of A, which is also equal to B over the sine of B. Well, now we have angle A and side length A. We also have side length B and we have angle B. So it's up to you whether you want to use either of these two ratios and set them equal to C over the sine of C. So it's your choice. We could go ahead and set it equal to B again, just because we know for sure that B is 70 degrees and side length B is equal to 13 centimeters, whereas we calculated side length A. So if in case we made a mistake in our first calculation, it might be better to go ahead and use the one that we were given here, okay, in the question. So I might choose to set C over the sine of C equal to B over the sine of B. So let's go ahead and do that. So we have C is unknown to us, so we're going to say C, just leave it like this. But it's over the sine of 80 degrees, because that's angle C. And it's going to be equal to 13 centimeters over the sine of 70 degrees. Okay, and again, I'm just rearranging this equation to solve for C, so I need to get rid of my denominator. I'm going to cross multiply, okay, to get rid of that sine of 80 degrees. And my answer is going to be that C is equal to 13 centimeters times the sine of 80 degrees, all divided by sine of 70 degrees, the sine of B. And my answer here, I can do this in one step in my calculator. Okay, and my answer is going to come out to 13.6 if I leave it to one decimal place. And there is my side length C, 13.6. So I can come back up to my diagram and fill that in. C is equal to 13.6 centimeters. So sine law is a really simple law to use. We do have to have a side and an angle relationship. So if we're using sine law, we need to have we have actually, if you have a look in your data booklet, it gives you a breakdown of what you need to have in order to do this. But essentially, you need to have a side length and an angle that are opposite from each other. And for the whatever, if you're looking for another side length, you have to have the opposite angle. Okay, or if you're looking for an angle, you have to have the opposite side length. And that's really important when if we're going to use sine law. Solve for the unknown sine length here. This time we're actually working backwards. So we're given sine law and we're going to sketch a triangle that matches this sine law. Let's go ahead and do this. This is not hard, although it is not using A, B, and C, which is okay. So let's sketch a triangle EFG that corresponds to this ratio. Okay. Well, one of the things I know right away, just by looking at this ratio here, is that this angle of 50 degrees must be angle E, because I know in sine law that we always write the ratio of a side length and its opposite, the sine of its opposite angle. So I know that this here, E over the sine of 50, must be E over the sine of big E. Okay, so in my triangle, I know for sure that angle E is going to be equal to 50 degrees. I could allow this second ratio here. This could be f over the sine of f, or it could be g over the sine of g, because those are the other two angles in my triangle and the other two side lengths. So it's up to us what we decide. Okay, there's more than one right way that we could sketch. There could be two different triangles here that I could sketch. So I'm going to go ahead and I'm going to sketch an acute triangle to the best of my ability here. Okay, where all three angles are less than 90 degrees, and I'm going to make this angle E, and it's going to be equal to 50 degrees. Okay, now again, it doesn't matter here how, there's more than one right way to do this. I'm going to go ahead and make this EFG, okay, like this. And I have to choose, do I want h over the sine of 60 degrees to be the ratio of f over the sine of f, or g over the sine of g? I'm going to go ahead and just choose this one. Okay, so I'm going to let 8.0 over the sine of 60 degrees be equal to f over the sine of angle f. So that means that this is angle f, okay, and this is side length f. So let's go ahead and label that. So angle f is 60 degrees, okay, and side length f is going to be the side that's directly across from angle f, and it's going to be equal to 8.0. All right, great. I can also label the rest of my triangle now. So the side length across from angle E over here is going to be side length E, and the side length across from angle G over here is going to be side G. So I've gone ahead and labeled this. Now we can use sine law and we can solve for the rest. Okay, so let's go ahead and do that. So well, where do we want to start for this one? We have a choice. We could right now, well, because we see that we have two of three angles, we could figure out what angle G is right now. That would be really easy to do. So let's go ahead and find angle G. It's going to be equal to 180 degrees minus those other two angles. Okay, so we get 180 degrees minus 110 degrees, which is equal to 70 degrees. So I'm going to go ahead and put that in. Okay, and now it's up to us whether we want to start by solving for side length G or side length E. Let's just go ahead and first find side length E. Okay, so I'm going to find side length E, so I'm going to use the ratio E over the sine of E, and in this case, angle E is 50 degrees, and I have to set it equal to a ratio that I know. Okay, well, there's only one that you know. You only have angle F and side length F. That's the only ratio that you can use. You don't know side length G, so you can't use that ratio because there would be another unknown in that ratio. So we have to use here F over the sine of F. Okay, we have to do that. So let's go ahead and fill those values in. So E over the sine of 50 degrees is equal to side length F, which is 8.0, over the sine of 60 degrees. And again, I'm going to cross multiply the sine of 50 on the bottom by 8 on the top of my other ratio so that I can just isolate E. So I get E is equal to 8.0 times the sine of 50 degrees, all divided by the sine of 60 degrees. And that's going to come out to be 7.076. I'm not giving any units here. I'll look over to the question, the side length I was given. F is equal to 8.0, just to get an idea of where I should round this number. I see that I have at least one decimal place here, so let's go ahead and round it to at least one decimal place. So this will be 7.1 as my answer. So E, side length E is equal to 7.1. Okay. Great. Finally, then, I can now solve for g. So step number 3, let's find side length g. And again, I can choose, I could now use either the ratio f over sine of f, or I could use the ratio e over the sine of e. The best idea is to stick with the ratio that you were given in the question because you know you haven't made it, there's no error there. So let's go ahead and set g over the sine of angle g, which is 70 degrees, equal to f over the sine of f, so 8.0 over the sine of 60 degrees. Okay, and again, I'm going to cross multiply that bottom number to get rid of the sine of 70 at the bottom. So I have g all by itself is equal to 8.0 times the sine of 70 degrees. There's the sine of g, divided by the sine of 60 degrees. And my value here for g is going to come out to be equal to 8.7 if I round it there to the first decimal place. And I've solved now, if I come back to my triangle, I've solved for all the angles and all the side lengths using sine law. So one last question here in our notes, and this is not a difficult question that we have. It's just asking us to prove sine law. So prove that all three of those ratios, the sine angle ratios, are equal for a given triangle that is an acute triangle. So if we were to go ahead and fill this, we're given all the information, we're given all three side lengths. If we fill in the angles here, so angle A is 50 degrees, okay, angle B is 60 degrees, and angle C is equal to 70 degrees. And I can now label my side lengths. So side length A is the one that's right across from angle A. So this is little a. Okay. Side length B will be 7.215 centimeters. It's right across from angle B. And across from angle C, 70 degrees, is this side length here, 7.832 centimeters. It's true that A over the sine of A is equal to B over the sine of B, which is equal to the last side angle ratio, which is C over the sine of angle C. This is true. Sine law tells us this. So if we were to actually calculate each ratio, we could compare them. They should all be equal. So let's go ahead and do that. So A over the sine of A is equal to what? Well, let's put the values in because this time we're given all the values. So we have 6.385 centimeters, okay, over the sine of angle A, which is 50 degrees. And if I calculate that out, I get a number 8.33. If I round it to the second decimal place, I get 8.33 here. Okay, B over the sine of B is equal to, well, let's have a look. The side length B is equal to 7.218. And if I divide it by the sine of angle B is 60 degrees. And so the ratio that I get, if I divide the top by the bottom, again, if I round it to the second decimal place, is 8.33. And finally, the very last ratio, C over the sine of C, is equal to side length C, which is 7.832, divided by the sine of angle C, which is 70 degrees. And again, if I put this into my calculator, I get 8.33 when rounded to that second decimal place. I can see here that all three ratios are equal. And this is going to be true anytime I use sine law. If I have the correct side lengths and the correct angles, then I'm always going to get three ratios that are equal. That's why we can choose to set any two ratios equal, because all three are equivalent ratios. That's all for now. We're going to continue on in class looking a little bit more deeply at sine law and solving some more difficult problems. I'd like for you just to try a few questions for homework on page 117, number 1 to 4 in your textbook. You can check your answers in the back of the textbook to make sure you're on the right track. And that's all for today. Thanks for joining me. Bye for now.